In this scenario, we're actually going to show how you can create gravity objects that aren't in the gravity factory, where we have Sun, Earth, Moon, Mercury, Venus, Jupiter, a bunch of common ones. But as you know, there's tons of different gravity objects in the solar system when you start considering asteroids, comets, all of those things, the Kuiper Belt objects. So how do we do that in Basilisk? That's what this scenario custom grav body illustrates. And this is a screen grabbed from Wizard. We'll launch this and show how this would work. But you can see how we're going to load up a custom gravity model and we're flying around it. And yeah, so it's an extra object that you can specify. That's not in the predetermined list of objects. And we can also include them in Wizard, which is a more recent ability, which is kind of cool. So here we're going to have, we want to create Sun, Earth, and Iwakawa. Iwakawa doesn't exist. Sun exists, and we can use the grav factory for making the Sun. We could use the grav factory for creating Earth, but just for kicks and grins, we're going to use the custom gravity properties to just make Earth, make our own Earth. You might have a classroom scenario where you want to show a case of what if the Earth had half the gravity or different size. And so, you know, you might want to make other Earths than what the default stuff are. So this is one way to do it. To specify the orbits here, you notice we're not using SPICE. SPICE is the JPL software library where you give it an epoch day time and it will tell you exactly where the planets and everything are if you load up the right kernels. Instead, we're going to use this module, Planet Ephemeris, which I've loaded up here already. This one is pretty simple. You can set up a set of planetary objects and then specify their positions via simple classic orbit elements. And it then creates the output message. It's the SPICE planet message. So it's the same output message that SPICE would generate. It's just created using classic, or Keplerian motion of a heliocentric object. So we can specify Earth's orbit to be what we want it to be, and the asteroid's orbit to be what we want to be, and go from there. So that's the module that we will use instead of SPICE. And actually, I should have shown that in here. I didn't. So we're going to connect that to feed the positions of these three, and that'll be our simulation. The outputs look kind of boring here because we're moving in a circle around an asteroid, but it will look much more fun when we look at it inside Wizard. Let's go to the script. So what's happening here? We are doing a simulation. Once again, we're loading up our simulation base class, creating the Basilisk Python architecture that we need, SCSim. We're making a single process. We're adding a single task to this process, and we're going to be running it every 10-second time step. I'm actually I'm running it for 1,120 minutes. I'm setting the simulation time here already. And now we're getting into the actual code. We will need this Planet Ephemeris Basilisk object. This is the one where we will specify a set of objects, celestial objects that we're going to be providing gravity for. So how do we do this? We're going to give it a model tag. We add it to the task list. That's kind of trivial, so it gets executed. Then one of the commands you have to specify is set planet names, and it expects a list of strings. So I'm going to have Iwakawa and Earth. Note the order. The order will be important. There's several things we have to set up here, and every time we will have to now be consistent. Iwakawa first, Earth is second. So that just sets up the basics. We'll add more things to Planet Ephemeris later on. Next, we want to find the orbit elements. So from Planet Ephemeris, you can do this. This creates this message payload that allows you to specify the orbit elements that it expects to get. This tells it, this is true anomaly at epoch, actually. Sending node, argument, periapsis, inclination, eccentricities, and semi-major axes in meters. Don't forget to convert to meters. Everything is in meters. So that creates that message payload. For the asteroid, we do the same for the Earth. It's 1 AU, slight eccentricity, slight inclination. We're just setting up the classic Earth and then fit it here at epoch at 270 degrees into orbit. So we've got those two messages specified that we're going to need. Now, in our what was it called? Planet Ephemeris module, there's a vector we have to set that is a vector of these classic element sets. So this will be a two-dimensional list. And you notice we give the elements of the asteroid first, then the Earth. We have to be consistent, otherwise this will be mixed and matched. Then we also specify the right ascension of each of the objects. These ascension, declination, local sidereal time, initial local sidereal time. Those are all classic things. They're basically Euler angles that they use in astronomy to specify the orientation. And then we also give a rotation rate of the planets. So they rotate typically about the 3-axis, and how fast are they rotating and spinning. So we specify the asteroid first again, and then the Earth, which orbits about, I'm just setting here 20, it takes it 24 hours to orbit, which is an approximation. I know it does 361-ish degrees in 24 hours, not 360, but close enough. So whereas the other one, orbits in about 12 hours, the asteroid. So you can see we're now consistently specifying for each one. And this is 2 dimensions, 2 celestial objects. You can make a whole series of them. You just have to be consistent in the order and then all the values that you provide. So now we've kind of populated that one. I'm going to show how we can still use Graph Factory. In fact, it will make your life much easier if you still use Graph Factory, because at some point, we have to add these graph bodies to the spacecraft so it knows, whoa, something of this mass is at this location. All this module does, Planet Ephemeris, is it's going to spit out the position and velocity. It has nothing to do with how massive is that object. We haven't specified that yet. That'll be in part of the graph body data. So we'll do that in a second step. So I still recommend using Graph Factory. So we're creating an instance of that. And for the sun, we can do that. Create sun, we're done, right? It made the sun with the defaults and everything. And we're good. The sun will just be at the origin, because we're not going to be hooking up an input message to the sun. So it's going to be at the heliocentric origin, which makes sense. Now, to set up the asteroid, we have to specify the mu, the gravitational constant, again, using meters, not kilometers, in the units. And then I can use this handy command from the Graph Factory. Instead of create Earth, create sun, create moon, there is a create custom graph object. And the benefit of using this is you now specify the name, so it knows what to connect and what to label it in Wizard and other things. And you specify the gravity. So how massive is this gravitational body, right? We're just doing right now a point mass. I'm not specifying any, I could also load up spherical harmonics like we did earlier. I didn't bother here. I'm just doing a bunch of point masses right now. It also returns the handle to this gravity body data class that you just created. So as before, we had Earth dot is central body to true. Here, we're going to set asteroid to is central body. So when we specify the spacecraft position and velocity, it'll be relative to the asteroid's location, not the sun's, not the Earth's location. Next, right, when we just create an object, by default, there's a message in there that's not connected. And if nothing's connected, then it's just going to go, it must be at the origin. That works for the sun, and we'll take advantage of that. But for the asteroid, we don't want it to be at the same location as the sun. It should be at the location specified by the output of this one. And so this one, this gravity planet ephemeris module outputs a vector of planet spice messages. And the order was asteroid, then Earth. So the 0 slot is the first one. And so the first output message is connected to the asteroid's planet body in message in this one line. So here we're directly connecting them. When we did this with Spice, that create Spice interface did all this for you actually under the hood. Here we're doing it manually. To do the Earth, again, we could have done Earth within the Gravity Factory. I'm just doing it here. To do the Earth, I have to specify the gravity mu. There's some optional arguments in Great Custom Graph Factory that's such as radius of the equator, because I need that to draw the Earth. So otherwise it doesn't know the size of the Earth that it's going to be drawing in Wizard. So I do specify that. Whereas Iwakawa in Wizard, we're actually going to upload a custom OBJ CAD model of Iwakawa. So it's going to look really cool. And as before, we're doing this manually. So Earth's planet body in message has to subscribe to now the second slot, which is slot number 1 of the grav body ephemeris module planet out messages vector. So that connects now. Now these Iwakawa and Earth will have the right locations at different time steps, which is nice. and the sun will just be at the origin, which is fine. So next we create the spacecraft, add a model tag, and this is not the standard line. Because we use the Grav factory to create custom Grav objects, it actually added these custom Gravi to its dictionary list. So that same line we've always used is just going to pull all three objects and attach them to our spacecraft. So you don't have to change anything. So that's kind of cool. And don't forget to add the spacecraft to the tasks, otherwise it never gets executed. Now we have to set up the position relative to the asteroid. So I'm going to call from orbital motions just an orbit element set that I can do math on. So I want it to be 500 meters away. Iwakawa is pretty small, so I don't want to be too far from Iwakawa. Slightly eccentric, inclined. You set all the elements, and then I'm using my elements to RV function to convert orbit elements to the classic position velocity vector. And then here, as before, I'm setting it. But again, because the asteroid is set to be the central body, these position and velocity vectors here are set relative to the asteroid, not the sun, not the Earth. And mu is mu of the asteroid, actually, yes. So that will make sense. It's consistent. Next stuff is pretty standard. We want to record and plot about 100 data points. So I'm going to set up a recorder for the spacecraft out messages. I'm also setting up a recorder for the asteroid out messages. So the gravity body ephemeris out, I'm going to record that one. Of a vector of messages, you just have to tell it which element of that vector of output messages do you want to record, and it will do everything for you. For Wizard, you will see here, this is standard setup like before. I do want to show spacecraft labels, but here I'm loading up a custom model for Wizard. I'm specifying a path where I have an OBJ file for Iwakawa, and it's going to load it up and scale it and draw it. So that way Wizard doesn't show Iwakawa as just a sphere of a certain radius, but it will actually use this model instead and draw that to scale. The rest of the script is normal. We initialize, we configure stop time, we execute, and then we pull our data. Here I am manually, well, Spice I could set a 0 base, saying, hey, everything logged should be relative to Earth or this asteroid. Since I'm not using Spice, I have to, in post-processing, take my spacecraft position, which will be now relative to the sun. Everything's in a heliocentric frame. And the asteroid position, which is also in a heliocentric frame, and take the difference. That'll tell me my trajectory of the spacecraft relative to the asteroid, and then that's what I plot. If I run this, doesn't look that exciting. We can run this quickly. You will see the motions. It's a circular orbit around an asteroid, so it's a bunch of sine waves as you would expect. Nothing too exciting, but it gets more fun if you actually look at this in the Wizard. So I'm going to load up a file that I already recorded earlier, and if we now visualize this, you can see, doesn't that look cool? Or you can go around and, look at the asteroid and, where are you relative to it? And then the asteroid tumbles beneath you as you go through the simulation. Again, here we just model the asteroid as a point mass, so my orbit is actually a circle. If you wanted to include, go find the proper spherical harmonics of an asteroid, you could have loaded those up and had a more complex gravity field be evaluated. That could have worked too. So anyway, hope you had fun with this one. What did we learn here? What are the takeaway messages? Is, well, we have these create Earth, create Mars, that's fine, but sometimes you might want to create Bennu. You might want to create a Ceres or some other object that's not in our catalog, and you can do that. You can make custom gravity objects, and that's what we're showing here. If these are in Spice, because you can load up the right Spice kernels, you can connect them to Spice, and there's some tests you can run and see. There's also scripts that do that, but you just may have to do it manually versus the other stuff. But here I'm also showing you how you can use planet Ephemeris. If it's just near the Keplerian, you just want to go look, the asteroid is here on this orbit, this semi-major axis. It will just, spit that out for you without having to use Spice. So you can see the flexibility and power that you get here. Hope you enjoyed.